All right, one more time. I want you to graph me this function, but first I want you to tell me what each part, each change in it is going to do to it. What's the plus 2 going to do? It's going to go up 2. When it's on the inside, it's right or left, but it's opposite what the sign says. If that's a minus, you're going to go right for. Okay, and then we have a negative in front. So does that flip over X or flip over Y? Yeah, that's flip over the X. So in other words, the thing's going to be upside down. Okay, then I suggest that you do a little thinking, the big question of the day, what shape is a cube root?
Sideways Scrabble.
Circle.
It's cubed, so it's a Scrabble. But is it vertical or is it sideways?
Sideways.
It is a sideways Scrabble. So, normal sideways Scrabble is low on the left side, high on the right side. Okay, if this one flips though,
It's going to be a high on the left side.
the part that's below is now going to be above, and this part that was above will now be below, so it's going to go that way. Okay, what are the coordinates you use to plot a Scrabble?
1 and 1, 1 and 2, 8.
Okay, so the 0, 1, 2, is it going to go on the left column or the right column?
The right.
0, 1, 2 is going to be the right column, that's your Y coordinates. And then you're doing cubes, so if you cube those numbers, 0, 1, 8 is what you're starting with. Okay, so if I plot that, but remember we want it to be like this blue line here, we want it to be high on the left side, so 1, 1 and then 8, 2. It's going to be over there. Move the graph. Ah, sorry, guys. Sorry, guys. I was so worried about getting that across. Sorry. Yeah, we need to go right 4 up 2. 1, 2, 3, 4 up 2. Make yourself a new origin. That's where you count everything from. Then count your 0, 0, your 1, 1, and your 8, 2. 1, 2, 3, 4, 5, 6, 7, 8, 2. We're up over there. And then on the right-hand side, my 1, 1 will go down, and then I'm going to actually go off the square. 1, 2, 3, 4, 5, 6, 7, 8. I'm actually going to be down over here somewhere. I'm going to erase it again in a second, but yes, I ran into the next box, sorry. Okay, you all, and by the way, you will never ever be allowed to use your calculator on this section. You will not be graphing these on a calculator to figure it out. If you just type this function in your calculator, it would graph it. Just go to a graph page and punch in the function. It graphs it. That's not a problem. All right. Okay, a second one. Let's do a little fraction action here. I shouldn't have done that first. Hold it. I better check on something. Don't do that one yet. Let's do something nice and basic. 2 minus 9.
Yeah.
Okay, let's do that one first. What shape is it?
Parabola.
It is a parabola, so we know it's our basic U shape. Okay. Cody, where's the minus 9 going to make us go? Wrong. Down. Where's the plus 5 going to make us go? Left 5. And then the 2, that's the part I'm worried about. Do you remember what to do? If you take your normal values for a parabola, Cody, end it.
0, 1, 2, 3.
And we normally do our 1, 4, 9. What does the 2 change? Times which? The x's or the y's? It always changes the y coordinates. If there's a number on it, it changes the y coordinates every single time without fail. So we would take all of those times 2, in which case we would get 2, 8, and 18. That's our y coordinates. On every single graph, if you have a number in front, you take it times the y coordinate, always. If it was a -3, if it was a negative, me personally, I would just know that the negative flips my graph upside down. And then you have to multiply it all by 3. That would, I mean, you could multiply them all by -3. On a parabola that would work because you're going to go down, but on some of the other graphs, that might confuse you. Okay, so then when I plot it, I am left 5, down 9. 1, 2, 3, 4, 5, down 9. I am clear down here as an origin starting point. But actually that's good if I have to go up 18 boxes here. So I would go 0, 0, 1 over 2 up on both sides since it's a parabola. 2 over 8 up is going to be 1 short of the axis. And then 18 up. It's going to be 1 short up here.
2 short.
If this is an 8 up, that'd be 10 more, wouldn't it?
Yeah.
I'm not crazy. And so you get a long, tall, skinny parabola.
Oh, yeah.
Okay, I got one more, or actually I got 2 things I want to ask you about. Oh, 2 things you should have noticed on your new assignment sheet while I'm writing here. On your new assignment sheet, it tells you how many problems you have to do, and it specifies, in this case, for this chapter, at how many graphs you have to do. So your assignment sheet says the minimum required. There's no doubt now. Okay, which graph is this? It's a fraction. It's either a hallway or a butt crack. How do you know? Hallway, there's no square. Okay. So the +4 is going to make us go up 4. The +2 is going to make us go left. Okay. So get that on there first. Up 4, left 2. And then, since it's a hallway graph, what do I need to draw through that coordinate system? That's where my asymptotes go, since it's a hallway. Going across, going across. Oops, I am off, aren't I? Oops. Yeah, sorry, I counted from the wrong axis, big time. Whoa, wow. Why didn't you guys tell me I was messing that up? Thanks.
Hey, you erased some of your problems.
Okay. Sorry, yikes. Okay, try that again. Left 2, up 1, 2, 3, 4 is here. And then I can put asymptotes in. Okay, now, what was the only point you plot on this one? 1, 1. But since there's a -3, the y coordinate gets multiplied by, technically you say -3. Actually, I would prefer you to think the negative is going to make these flip. A hallway is normally in first and third quadrants. So if this one flips, where's it going to go? Second, fourth. It's going to go to the opposite. No. It flips where the graph is. So now this is 1, 3. So now I'm going to go 1 and 3 down, and 1 over and 3 up on this left side, so that the negative just flips the graph. And then, okay, on these graphs, once you hit that point, as you come up your asymptote, once you hit that point, that's where you break for the other axis. And so, we'll start off that way. This takes practice, pure and simple. there's a few book problems, and on the book problems, they reverse it on you, and so I want to show you one like the book problem is going to be.
Did you give us the handout yet?
Nope, going to in a moment. Okay, in the book, they're going to give you the graph, and they want you to write the equation.
Seems simple.
So, I'm going to give you this graph. Do you need me to move? I can move. It's 3 over 6 up. My point is 3 over 6 up. Actually, I think I want to change because I just did that one, rat. What else would be a good one? Oh, I could do that. Oh, that would be really evil. I probably shouldn't do that. Okay. It's a half parabola, okay? I'm off the top. Okay? And I just said this is 3 over, this is 6 up. Half parabola going that way. So, first thing you need to do is what equation gives you a half parabola? Which one is it? Square root. Anything parabola curved is square root. So this is square root. We know we're working with square root. Okay? I shifted, it went right 3 up 6. So how do I make this go, how do I make the equation go right 3 up 6?
Right 3 would be negative
Plus 3.
Does the 3 go inside or outside?
inside.
Left and right is inside.
Negative 3.
So it would be minus 3 would make me go right. When I'm inside, I go opposite.
Plus 6.
Up 6 is up and down. That's outside the function. And so it stays the same sign, plus 6.
Isn't there a 2 on the outside?
Okay, why does Luke think there's a 2 on the outside? Because normally on this we would do our 1, 2, 3, 1, 4, 9. And it should be 1 over 1 up, but I'm 1 over 2 up. So I doubled all my y coordinates, didn't I? So therefore, yes, there would be a 2 out front, because I didn't leave myself room.
And wouldn't you have a negative inside, like negative outside?
By that time, like 4.
Oh, thank you, yeah, oh, shoot, I flipped that. Okay. No, I forgot, I didn't mean to be that mean, I wasn't thinking about that back. Okay, it's flipped.
Yeah, I was going to say it's backwards.
Okay, does anybody remember how
It'd be a negative 2.
a negative 2 would make you go upside down.
No, it'd be a negative 1.
It needs to change the negative on the inside. So what they do, I'm out of room. I guess I'm going down here, I'm out of room. So what they do, you have to put a negative in there. So it's like saying I have a negative times x minus 3. Which actually, the way a book would write it is they'll make it become 3 minus x. They'll reverse the order.
Wait, why do you have to do that?
It flips, it's going left, so normally it should curve right. Normally a square root curves off to the right, and it flips.
Yeah, but I thought the negative 3 made it do that.
The minus 3 just made you go right 3 units.
Yeah, but now won't your 3 go left?
No, it won't. Because before you can decide, this is the one, square root's the only one that'll do this. Before you can decide whether you're left or right, if you were going to graph that one, you would have to pull the negative out and switch it back to x minus 3 before you'd be able to tell where to shift it.
That's tricky.
That's tricky. That's why I was kind of doing square root.
Oh, man.
Tricky. Okay.